All right, in Chapter 7, we're going to talk a little bit about scientific notation, which you've already talked about in your science class and then also other math classes. The goal of this is to connect numbers in scientific notation with the exponent rules that we just got done doing. So by the end of this lesson, you should be able to simplify expressions in scientific notation. So let's remember what scientific notation is. It's a way to write either really, really large numbers or really, really small numbers more efficiently. So instead of writing like 3 billion with all the zeros, we're going to write 3 with an exponent. So a number in scientific notation is written as the product of two factors in the form a times 10 to the nth power, where n has to be an integer, which means a nice pretty number like 1, 2, 3, or 4. And a has to be somewhere between 1 and 10. So something like 10.6 times 10 to the 8th power is not in scientific notation because this number is greater than 10, which doesn't work. So here's some examples. This would be an example of a big number. So would this, where this would be an example of a really small number. And it has to do with the exponents. So remember, like we talked yesterday, this would be like 3.4 times 10 6 times. And I could keep writing this out 6 times. This would be 13 times. Or one like this, 2.1 times 10 to the negative 10th, I would divide by 10 times, which means that I'm going to keep getting a smaller and smaller number out. So this part's review. Let's just double check if we can tell which ones are written in scientific notation and which ones are not. So the two things that you're looking for is this number somewhere between 1 and 10, and is this a nice pretty number? So for this one, yes and yes, it is in scientific notation. For this one, this number is okay, it's a 4, but 52 is not a number between 1 and 10, so this is not in scientific notation. This one, nice pretty number, that works again, but this is not between 1 and 10, so this is also not in scientific notation. So this part you did in your science class and in 8th grade. Let's take these numbers and put them into scientific notation. So chances are when you were taught this, you took a decimal point, so here it would exist there, and then you counted your way over until you decided to stop. Now remember, we're going to put it between the 2 and the 6 to make 2.67. We don't want to make 26.7 or 0.267 because we have to have a number in between 1 and 10. And then we're going to do times 10 to the power of, we moved the decimal over 1, 2, 3, 4, 5 times. So that means we would have to multiply 2.67 by 10 5 times to get back to that number. So let's try one that's really, really small like this. We're going to do the same thing. Here's our decimal point, and we're going to count how many times we move it until we get a number in between 0 and 10. And we moved it 1, 2, 3, 4, 5 times this way, but because we moved it to the left, it's negative 5. So if you go this way, it should be a negative exponent, and if you move this way, it should be a positive exponent. Where these next ones are a little backwards, we're taking these numbers that are already in scientific notation and putting them into standard notation. So if we do B, we have 5.07, and I want to multiply this by 10 times. So we know anytime we multiply something by 10, it just gets bigger. The decimal moves over one spot. So when I look at this positive number, this tells me that it's going to be a really big number. And the direction I need to move to make it to a big number is to the right. So I'm going to move it to the right 1, 2, 3, 4 times. And then these open humps that don't have a number in here get replaced with zeros. So this is really 50,700. Or we can do the same thing with this. I'm going to write out my decimal point. This negative tells me that it's going to be a small number. So instead of moving to the right, I want to move to the left. 1, 2, 3, 4 times. So again, we'll replace these humps with zeros. So it's 0.00056. So let's try something a little different. You've done stuff like this before, but maybe not to this extreme. So what we're going to do is multiply one number by something that is in scientific notation. Now, in order to do this, we only multiply the number part together. So 2.5 times 6 is all we have to multiply. So we end up with 15 times 10 to the third power. This is not in scientific notation, though. We have to change this into scientific notation. So remember, it's got to have the decimal right here. We have to have 1.5. But that also changes the exponent here. So I want you to stop and think about the number. Because I moved it over this way, I divided by 10. And in order to get this to the number I want, which had 3 here, I now have to multiply by 10 4 times to get to the number that I want. So when you think about it, when you move left, you add to your exponent. This is the answer in scientific notation. Now this one over here, we're going to do the same thing. We'll do 0.4 times 2, and that gives us 0.8 times 10 to the negative 9th. But again, this doesn't work. That number is not in between 0 and 1, so I have to move the decimal over 1 spot. And if you think to move it over this way, I'm multiplying by 10. And in order to get back to the number I want, I have to divide one more 10. So it's times 10 to the negative 10th. So if you move right, we subtract. All right, now this is where we're actually going to apply the rules that we learned. So this is the only stuff that should be new for you. In order to multiply two numbers in scientific notation, we multiply the numbers together like we just did. And then with these times 10 to the 8th and 10 to the 3rd, we're going to do exactly what we've been doing. We have the same base, so we can add the exponents. So 2.5 times 6 was what we did here, except this 2.5 didn't have an exponent on it. So we still get 15, and it's still times 10 to the sum power, but if I have 8 tens here and 3 tens here, that means I have a total of 11 tens. And then just like before, it's not in scientific notation, so we got to move this over. So this will be 1.5. And just like we said back here, if we move to the left, we have to add to our exponent. So this will now be times 10 to the 12th. And remember, the reason that that is because I'm dividing by 10 to move it here, to make this number smaller. So to undo that, I need to add one more 10 on there. Same thing with these next couple. So let's do this next one together. I'm going to multiply the numbers, 1.5 times 3, which is 4.5. And then it's times 10 to the, I'm going to take these two exponents, and I'm going to add them. So negative 2 plus 4 gives me 2. And this number does happen to be in scientific notation, so we're done. Let's try one with some division. So just like anything else that we've done before, you divide the things that are the same. So 2 divided by 8 is what we're going to divide here. And we can divide 2 divided by 8 and get 1/4 or 0.25. And then when we divide these things, remember we subtract the exponents. So 3 minus 8 is going to give us negative 5. And unfortunately, this is not in scientific notation, so we're going to move this decimal over 1. And remember, when we're doing that, we're multiplying by 10. So to get it back out, we have to divide by one more 10, which would make it to the negative 6th power. Let's try another one. This one right here, we divide the numbers. 7.5 divided by 2.5. That gives us 3. Times 10 to the, this thing dividing, remember we got to subtract. So it's 12 minus a negative 4. 2 negatives make a positive, so it's 3 to the 16th power. And we're done. So really, these last two slides are the only two things that should be new. The rest of it you've been exposed to before. So you should be able to simplify expressions in scientific notation. Go back and finish all the ones that we haven't, and you can prove to yourself that you can do that. Hope you enjoy your weekend, and I will see you on Monday.